Hi, in this video I'm looking at using mathematical induction to prove that the sum of all positive odd integers up to a given number n is n squared. So that's that I want to prove that our proposition of n is that if I add up 1 plus 3 plus 5 plus 7 plus all the way up to any given odd number. So we need to write any given odd number, which is an even number, minus 1, or an odd number. And I want to prove that that is the number that I get up to squared. And I'm going to do this for all n is an element of our positive integers. So the first step of mathematical induction is to show that it works when n equals 1. So we want to prove p of 1. So first we have our first term in our sequence, and I want to show that that is 1 squared. So my first term in my sequence is 1, and I want to show that that's how many terms I've got. N is 1 squared. And so our left-hand side is the same as our right-hand side. So therefore, this is true for n equals 1. So that's our initial step, show that it works for the first term. The next step is that we show that, or assume that it works for any term. So we're going to assume that p of k is true, so for any term. So assume that p of k is true. So it's going to work for any integer k. So this means that 1 plus 3 plus 5 plus 7 plus going up to any odd k is going to be k squared. So that's our first part of our inductive step, is to assume that it works for any integer k. So I'm going to show that my expression works for any k also being an element of our positive integers. Our next step is, now that I've assumed that I can do any integer k, I've got to prove that it works for our next term, k plus 1. So if I think about being able to move from what I've assumed is true to our next term, I know what I've assumed is true is that the first k terms work. So that would be everything up to 2k minus 1. And I know that that equals k squared, but I'm going to move on to the next term. So the next term would require me to add on the next term, which would be 2 times whatever n is, which in this case is k plus 1. So we have 2 times k plus 1 minus 1. And now, because I've added this term to the left-hand side, I've also got to add it to the right-hand side. So I'm going to add on 2k plus 1 minus 1. So now what I am required to do, now that I've gone from one assumed any term to the next term after that, I need to make this look like what this would be for k plus 1. So if I think about that, I have n squared. So I need to get this to be in terms of k plus 1, because k plus 1 is now n. So my aim, algebraically, is to try and rearrange this so that it looks like k plus 1 squared. I want to consider being able to get to that, because my right-hand side is n squared. We're going to prove that it works for n is k plus 1, so I want to try and get this to be k plus 1 squared. So I need to do some algebra to try and get k plus 1 squared out of this k squared plus 2k plus 1 minus 1. So let's have a look at doing that. I'm going to start off with expanding this out and see if that helps. So I've got 2 times k is 2k, 2 times 1 is 2, and I still have minus 1. So now if I sort out this plus 2 minus 1, I've got k squared plus 2k plus 1. So looking at this, I've got k squared plus 2k plus 1. I can now try factorizing this. And so I've got what multiplies to make 1 and adds to make 2. Well, that's 1 and 1. So that gives me k plus 1 times k plus 1, which is k plus 1 squared. So I have shown that by moving to the next step from my sequence, I've managed to obtain an expression that n being k plus 1, so when n is squared, k plus 1 is squared. So that means I've achieved it. So now I can write that, therefore, p of k plus 1 is true. And that means that by the principle of mathematical induction, my proposition p of n is true for all n is an element of our positive integers. There we have it, mathematical induction to show that the sum of odd integers up to 2n minus 1 is n squared. We have our initial step where I show that it's true for the first term. I then start my inductive step, assuming that it works for any integer k, and then I show that it will then work for the next term, which is k plus 1, and I am then done.